gravity will help to pull these hydrogen atoms together. The hydrogen atoms come together, and the force of gravity, the more and more, will create this very, very high pressure and high temperature area in the center of this cluster of hydrogen atoms. And that cluster, they will start to collide together by a process called nuclear fusion. Nuclear fusion is the hydrogen atoms inside that there's so much pressure and so much temperature, they will start to collide with each other and releasing a tremendous amount of energy. And that energy will help to form the stars. So stars are formed by nuclear fusion, and that is how stars continue to emit all their light and all their radiation, is by the process of nuclear fusion. That is nuclear fusion. So you have, the stars are formed because you have, again, the mass of the hydrogen atoms. The more hydrogen atoms you have, the bigger the star will be, the more massive the star will be. And you can see here the star's diagram. You can have an average star or a massive star, again, based on how much hydrogen atoms there are, how much of that gas formed into the nuclear fusion to form these stars. They could grow in size by having more hydrogen atoms, and then they could eventually explode into a supernova or into a nebula, and then they become a white dwarf, which would be the final stages of a star or a neutron star, or become a black hole. That is the life of a star. So you have the characteristics of stars on page 15 of the reference table. So here's the characteristics of stars. So you have many different stars, not all the stars, but some stars in our galaxy. So you have on the left side is luminosity, which is the rate at which a star emits energy relative to the sun. So relative to the sun, how much energy they emit, how bright that star is going to be. The sun is at 1, so therefore the other stars here, the sun is that's where we're located. That's at 1, and the other stars are based on that. So you see Sirius is about 10 times more luminous, 10 times more brighter than the sun. Spica is like almost 10,000 as bright as the sun. The surface temperature is how hot that star is on the surface, so it's relative. So these are relatively low temperature on the surface, and these are much higher. So Spica, they have a higher temperature. Betelgeuse have a lower surface temperature. These are small stars to massive stars, so small is on the bottom, and then these stars are much more massive. They are much bigger than the other stars. On the bottom, you also have the color. So you have Spica is blue. Again, it's high luminosity. It's a big star, and also it is high temperature. These are red. Betelgeuse is a big star, but it's low surface temperature and high in luminosity, and it is a surface temperature of red. Now, you also have the different stages of the stars. First, they start in the main sequence. Here is the early stage, it says. And then again, if the star gets more hydrogen atoms, it can grow in size and become a giant star or a supergiant star. But then, like we saw before, it could explode and become a white dwarf, which is a late stage star. So now the sun is right here, and the sun, that is our star. We are located around the sun. The sun is a main sequence star, and the sun is located in the Milky Way galaxy. Hi, this is Donnie Rudansky from Regents Made Simpler. And if you'd like that lesson, be sure to check out regentsmadesimpler.com, which is in the link in the description below. And you could purchase my full course for just $89 for the upcoming Regent exam. This is the only resource you need to do well on your upcoming New York State Regent exam. And in the course, you will get a 2-part Regents review of all the material you need to know in a simplified version, like you saw in that lesson. Plus, I have video review with visuals of past Regent exams. That is not just me explaining the material. That is also me, as you see in this picture, me with visuals explaining the correct answers and the incorrect answers as well. For just $89, that is less than one typical tutoring session. So you can go to regentsmadesimpler.com. That is in the link in the description below, and check it out. And if you scroll down, you could see the a preview of those Regent review courses and the video review of past Regent exams. Again, this is only for $89. That is less than one typical tutoring session, and you can get everything you need to know and learn everything in just 2 to 3 hours for your upcoming exam and do extremely well.